So, historically, what most high school, middle school, even early college kids learn is that there is a way to do the scientific method, a single method for walking through and figuring out the world around us. No, not even close to being the case. So we are going to use this right here as our framework for understanding how science is done. Please just understand that no real scientist does this and only this. I've worked in a number of different labs, and real science looks something like, okay, I have data, and it turns out all of this is wrong, so start from scratch again. That's a much more common way to do science. In fact, I was in a lab, and I spent about 6 weeks working on one little piece of a project, and I was really confident that this was going to work. And finished everything that I needed to do. The only thing left was to put the cells under the microscope, look at the green fluorescent protein, and show that these two proteins that are involved in a chemical cascade, that they actually did what we knew that they were going to do, right? Easy, just support the evidence, move on. Then they didn't, and nothing feels worse than going to the professor that is running your lab and saying, well, all of my work just failed. And the smile that he had on his face said everything that I really needed to know about that. Because he says to me, it's okay. That's great. That means we know one more thing that it isn't. So in real science, in actually getting out there and figuring out the world, I do want you to understand that this is typically not how science is quote unquote done. That being said, it does act as a really good framework for the rest of at least figuring out how to do science. So we're going to look at two types of investigations. Manipulative investigations are the ones that you typically think of when you think of science class. They're the controlled experiment where you go in and you purposefully change something, measure what the output is, boom, you're done. Okay? Observational ones, has anyone taken AP stats, or any stats really? That's all observation. It's figuring out what the connections between things that are already there. What are those connections? So rather than going in and manipulating something, you're just collecting data on what has already had an effect on something, okay? So to understand the natural world, first two things, you guys are doing these all day, every day, all the time, is to make observations and from those to make inferences. It's the first step in understanding how the world works, even if you don't move forward with setting up an experiment for it. When we're looking at the observation, we're just making general statements about the world around us, either using the things that we see, we hear, we taste, or we can use scientific instruments. Whatever the case is, it has to be very factual and very straightforward. No interpretation of what you're seeing. It's just straight up, there are windows, there are lights. Inferences are then going to give you some kind of further possible explanation of what those observations may be caused from or may be indicative of. So for example, you wake up in the morning and you look outside and your lawn is covered in little water droplets. What observation can you make? Okay, I look outside, there's water on grass, boom, done. That is the observation. What inferences can you make? Start with the most obvious. It rained. Did I see it rain? Did I observe it? No, it doesn't say that I did, so that would be an inference. Based on the information that I have, I go a step further and explain why it happened or something more. What other inferences could I have made, though, about why my lawn is wet? Maybe it's dew. What else? Sprinkler systems went off. My neighbor gave his dog way too much water and he tinkled everywhere. Some of these are far more likely, some are less. Maybe a giant walked through my neighborhood and splashed his cup of water everywhere. Some of them go into the realm of maybe not so likely, but nonetheless, the inference is based on our observation, and you can stop there. Most of the time you do. You stop there, you say, I don't need to investigate this any further. But if you then decide to move into the realm of investigating it, you are going to make a hypothesis and or a prediction. Okay? Now look, these terms are constantly used interchangeably, mixed around, misunderstood. I am not going to drill you on them. I am not going to freak out if you mix them up. In fact, I will sometimes use them interchangeably. For those of you that are okay with that fact, you can just kind of tune out what I'm about to say. For everybody that maybe is considering going into science, maybe doing research, maybe getting a PhD and doing real investigations as you get older, I do want to clarify, okay? So when you're looking at hypotheses, these are possible explanations that you're going to test. They might be very, very similar to your inference. In fact, if it's written down, maybe you can't even tell the difference between a hypothesis and an inference. Your hypothesis explains whatever, and you're going to move forward with testing. A prediction is based on that hypothesis, and that prediction is going to be that if-then statement of what you expect to happen to give support to your hypothesis. Okay? For example, one very famous hypothesis right now in science is that there is an increased number of people with allergies because we have so much less exposure to germs, right? There's just this relationship between the two things. That hypothesis can be tested with different experiments. And so if people have less exposure to germs, then they're more likely to have allergies. All that being said, so long as you understand that somewhere you've got to have that if-then statement, I'm fine. You're fine. We're all fine. Everybody's fine. Let's move on, okay? All right. We need to talk, regardless of if it's an observational experiment where you're just collecting data, or if it's a manipulative experiment, you have to identify an independent and dependent variable, okay? So when we're looking at that independent variable, it is what you are testing in your investigation. When you're looking at the dependent, it is affected by the independent variable, hypothetically, if there is a relationship between them, and that's ultimately what you're measuring, right? Easy, we get it? Of course not. Examples are always going to be very helpful for this. So, in this totally fictional, if you didn't pick that up, example, I tested something to see if it had an effect on something else. What is the thing that I was testing? What was it? The diet pill. Awesome. So I'm testing out the diet pill, and I'm trying to see if it has an effect on what? Good. It's very common for people to say a person or weight. I love, Monica, that you said weight loss, because that is ultimately what we're measuring for. Okay, so let's talk, or not, let's talk controlled experiments, because clearly the experiment that I have just laid out for you is perfect in every way, right? So, whenever, shh, you know nothing, you're just a high schooler. Oh, I shouldn't. So, what was our dependent variable again? That thing that we're measuring at the end to see what affects it? Okay. And what did we say would have an effect on weight loss? Okay. Here's the problem. I know you might not have picked up on it, but it is possible, hypothetically, that it wasn't the pill that caused you guys to lose weight. It could have been something different. I know, the look of surprise on your faces tells me everything I need to know. What kind of things could affect weight loss, just in general? Anything that could affect our dependent variable. Yell them out. Exercise, diet, genetics, right? A person's metabolism or their use of matter and energy. Well played. The amount of sleep. Absolutely. Surprise amputations will definitely have an effect on weight loss. Surprise, you're missing a leg. So, whoosh, that is not a good way to lose weight, trust me. Okay. So when we're doing a controlled experiment, the key idea here is that we are isolating one single variable, and only one, to have an effect on that dependent variable. Because if all of these different factors are now having an effect on my dependent variable, maybe it was the exercise that caused you to lose weight, maybe it was the diet, maybe it was just your genetics, maybe every January you just lose that, Christmas yummies. So we're going to call anything that could affect the dependent variable a controlled variable. And what we need to do is, control them. We need to ensure that exercise is not what's causing the weight loss, that diet is not what's causing the weight loss, that your genetics are not what's causing the weight loss. And what is the best way to do this? We set up two groups and we keep it the same. The only difference that should exist between you guys getting the pill and you guys not getting the weight loss pill should only be the weight loss pill. That way I can ensure that that is the only factor that is different. So what do we call the group that does get the weight loss pill? Okay. So when we're looking at that experimental group, it's whoever does get the independent variable. When we're looking at that control group, it is whoever doesn't, and it is very often that you'll have different treatment levels, different amounts of, maybe you get X number of milligrams of the diet pill, you get X number, and you get none. In those cases, it becomes a little bit more tricky to distinguish what is the experimental or control group. I want to look at now. So if we're taking a look then at our particular experiment, we said top left, that is the pill in this case. What part of the experiment is that? Our independent variable, and we only give the independent variable to which group? Our experimental group. We then can compare the experimental group to the control group, and what do we actually compare? Yeah, we have to measure something, and we always must be able to measure the dependent variable, or else it's a crappy dependent variable. What is something that we need to make sure stays controlled? There's the key term. A lot of people confuse controlled group with controlled variable. The controlled variables are the factors that stay the same in both. The control group gets the controlled variables, but not the independent variables. Okay?